Functional dependencies. What exactly the functional dependency? Or in short, we say FD. It's a relation between two attributes in the same table or in the same relation. So if there is an attribute, its values depend on values of another attribute, then we have a functional dependency. And we represent it as you see here, x to y. X to y. X is any attribute or group of attributes, not just one attribute. And y, the same. It could be one attribute or more. And x to y means y depends on x. If the value of x changed, the value of y will be changed. If the value of x is the same, the value of y will be the same. This means x affect or influence y. For example, you see here SIN, name, address, birth date. Name, address, birth date are changed if the SIN changed. Actually, this is a general example. Always in all cases, the primary key influences other attributes, which means if the value of the primary key changes, all values will be changes. That will be changed. That's obvious. But for example, ISBN and the book title. I'll give you another example from here. In some organizations, they have salaries depend on rank. Like they have employees rank from rank 1, 2, 3, 4, and so on. And always the salary depends on the rank. So all employees in rank 4 are getting the same salary. All employees in rank 7 are getting same salaries. But there is a difference between employee in rank 7 and in rank 5. Whenever the rank changed, you will see the salary is changed. Whenever the rank is the same, you will see the salary is the same. So this is the idea and the meaning of functional dependencies. We have here rules of functional dependencies. These rules are not so important for us, but let's look at this example. Suppose this is a relation R. So relation here means a table. This is the relation. The relation has attributes A, B, C, D, and E. These are the attributes of the relation. A1, B1, C1, these are the data, the real data. Then, what dependencies, what functional dependencies we have? A to B, A to C, A to D, A to E. So it means like A is the primary key. So when A1, we have B1. A2, we have B1. A3, we have B2. A4, we have B2. A5, we have B3. Okay, so B depends on A, and C depends on A. When A is the primary key, then all of them are depending on. It also follows that A to B C and A to B C D E. Look here at the example. What exactly the example wants to say? When we have A to B, A to C, A to D, A to E, we can join them together, so it's A to all of them. This is one of rules. We have many rules, but you know, guys, I don't want you to go through rules. No need. No need at all. But look here at this figure. This figure here showing the dependencies in a different way. We can represent or show the dependencies like from to x2, and we can show it like this example here, this figure here. When you look here, we have arrows. For example, project number to project name. Project number to project name. So project name depends on project number. When we have arrow, the direction of the arrow goes to the attribute which depends on the starting of the arrow. So the arrow starts from here and goes here, which means project name depends on project number. Why I tell you about the functional dependencies and I don't want to go through rules. Rules are not important for our topic, which is the normalization. What we need to do, we need to normalize our database. What is the normalization? You can find the normalization in the book I sent you. You know what? Let me open the book. It's better than searching here. At least you will have an idea where exactly you can find the information on the textbook. So I'm going to open it. Normalization. Chapter 12 about normalization. Chapter 11 about functional dependencies. Let's look at this. What I opened on the web. It's from your book. Exactly from your book. And chapter 12 in your book, which is about the normalization. Okay, what is the normalization? Normalization is something we needed to make sure that our design is good. What I mean by our design, I mean the relational scheme. We start designing the database with the ERD. After we finish the ERD, what we have to do, we map the ERD, so we create the relational scheme. Now, once we have the relational scheme, we must normalize it. Or maybe it doesn't need to be normalized, maybe it's normal, but we need to make sure it's normal. Why? Because the good design of database is a normal design. And we need to make sure we have a good design. Why? Because if the database is not in a good design, it will make problems for the system. You are creating or designing the database. How do you know it's in a good design or not? How? You are just making the design. If you remember, I told you about creating the ERD. I told you it's a matter of opinions. So your opinion could be different than mine, and all of them are correct in the ERD. Do you remember I told you this? And I told you it depends on the experience. If somebody has more experience, then from the beginning will create a good ER. But if somebody doesn't have, so what we can do, suppose you are beginner, you don't have enough experience in creating the ERD, and you are creating ERDs. And after you create the ERD, you map it and you generate or you create the relational scheme. How can you know your design is good or bad? Suppose it's bad. What's gonna happen? This could, the bad design of database could collapse the whole system. So you can imagine we are creating a system and it costs a lot of money and a lot of effort and a lot of time. Then, when the system is ready and the business organization starting using the system, it starts working good. But when we have more and more and more data, because of the bad design, it will start having problems, errors, and depend on how bad is it. It may collapse. So it's very, very important, very critical, very serious that the design is in a good design. How can we know? By normalization. We need to apply the normalization rules on the database, specifically on the relational scheme, not on the ERD. So it's like you are testing your database design. Is it pass or is it fail? If it satisfying the normalization rules, then that's it, it passes. If not, then it fails. So what we can do if it fails? Recreate the ERD from the beginning and then do the mapping? No, not that what we're gonna do. So what we will do, we will normalize it. We will normalize it. If x to y, then x is primary? No. If x to y, then the value of y depends on the value of x. There's nothing says x is primary key. Okay, so if we find there is something wrong about the normalization, we have to normalize it. So the word here, normalization, means make it normal. So our goal, to have a normal database. If the database from the beginning normal, that's it. No need to normalize it. If not, we need to normalize it. How? And look here. Let's look down in your book. What does it say? Normalization is the branch of relation theory that provides design insight. It is the process of determining how much redundancy exists, not just redundancy, many of problems. Redundancy is one of problems. The goals of normalization is to be able to characterize the level of redundancy in relation schema, provide mechanism for transforming schemas in order to remove redundancy and other problems. So we have normal forms. We should check our database regarding the rules of normal forms. Normal form 1, or first normal form, second normal form, third normal form, and BC normal form, BCNF. As you see here, it says BCNF is rarely used. So our goal to make sure the relational schema shows that it's in the third normal form. The first normal form is not enough. So if your database achieving normal form 1, okay, that's good. Check normal form 2. If it achieves second normal form, that's good, but you have to check the third. If it achieves the third, that's it. You don't need to check the BCNF. So you need to understand the rules of each one of normal forms. These normal forms, maybe somebody will say, why we have to check first, second, third? And why we have first, second? Why we don't have only the third and that's it? If you ask this question, this is a good question. And the answer is, these forms were not created at the same time. It was by, sorry for the background noise, it was gradually, like the scientists of database, after they find there is problems of the design, they made something called first normal form to enhance the design. Then they found even normal form, first normal form, still has problems, so they made normal form 2, or the second normal form. They found the second normal form still has problems, so they made the third normal form. That's why we have 3 normal forms. Then 2 scientists, their names Boyce and the other one, his name is Cod, they made something specific about the normal, the third normal form, to make some changes on it and make it under their names, Boyce and Cod normal form, and this is rare. So what do we need to do? We need to check our database against first normal form. If the database in normal form, like why I say in, if the database achieves rules of first normal form, then it's in the first normal form. If the database achieves second normal form, then it's in the second normal form and the first normal form, because everything in the first normal form is available in the second one, and everything in the second is available in the third, but there are some additional things in the third. So if the relation or the database in the third normal form, it means it is in the second and in the one, but not the opposite. The first normal form, what does it say? It has one rule. The rule says only single values are permitted in the intersection of each row and column. There is no repeating groups. Let's look at the example. The primary key of the new, okay, let me read from up. To normalize a relation that contains repeating group, remove the repeating group and form two new relations. Guys, always, and I literally mean it, always, when we need or when we want to normalize, we split the relation into two relations. Always, normalization means splitting, because that's the only solution. When we have uh, when we have a database which is unnormalized, or it's not in the first normal form, how can we make it in the normal form? How can we normalize it? Splitting. That's the only solution. But not splitting randomly, just a split. No, we have to split following rules of normalization. So when we split, we will have two relations, and each one of them is normal. How we know? By applying the rules. Let's look at rules and see how to apply them. But before we do, just I want you to know the normalization means splitting. The normalization, look here, to normalize a relation that contains a repeating group, remove the repeating group and form two new relations. Split. How to split? It's not random. The primary key of the new relation is combination of the primary key of the original relation plus an attribute from the newly created relation for unique identifiers. Let's look at the example. Look here. Student grade reports. This is a table. Suppose we have a table called student grade reports. So, what are the attributes? Attributes are student number, student name, major, course number, course name, instructor number, instructor name, instructor location, grade. Okay? In the student grade report table, the repeating group is the course information. A student can take many courses. So look here and imagine. Suppose you need to fill the details about the student in this table. You will put the student number. He has or she has one number. Student name, 1. Major, 1. Now, how many course number we will have? What do you think? Here in this table, we can put 1. But logically, it should be many. Yes. So if we want to put more than 1, we can't. It will be group. So that's what the remove the repeating group means. When we have such relation, this relation is not achieving the first normal form. It's not in the first normal form. If you have this table, then definitely it's wrong. Definitely it is in a bad design. So the question, how can we know? How can we know if our design is bad? You have to take all relations, all tables, one by one, and look at each one of them. If you find anyone has repeating groups, then it's a bad design. It doesn't fit the first normal form. Okay? So do you see an example of a table doesn't fit the first normal form? How it looks like? It has repeated values in the same record or in the same row. Because here, what can I do? If I want to let the student has 4 courses, I will repeat the student number, the student name, major, first course, number, name, instructor name for the first course. Instructor number for the first course, instructor name for the first course, instructor location for the first course, grade for the first course. Now, the second course, repeat student number, repeat student name, repeat major, no change. Course number will be different, course name different, and other information are different. If the student number is the primary key, this can never be happen. Why? Because the student number cannot be repeated. If not the student number the primary key, if course number is the primary key, when we have another student taking the same course for the previous student, then the course number will be repeated. So we will have the same problem. Which means this design is bad in all cases. What we can do? We can split it. We can normalize it. Look at the normalization. What we are doing here. Student. What the student has. The student has student number, student name, and major. If you look back, what are the attributes which belong to the student only, not to the grade, not to the course. Student number, name, and major. Everything else will be repeated. So we take what are not repeated and put them in a separate table. Then we take all the repeating values and put them in another table, but we add the primary key there. Look here. Course number, course name, instructor number, instructor name, instructor location, grade. All of these depend on the course number. So I put the course number as a primary key, but I have to bring the student number from the first table. So both of them are primary key, part of the primary key. Now, I don't need to repeat student name, student number, and major. Here, of course, I will repeat the student number, but with different course numbers. Student number 1, course number 1. Student number 1, course number 2. Student number 1, course number 3, and so on. Any questions? Okay. Now, student relation, the first one here, it's the student number, but maybe they forgot to put the line under, but it's the student number. In the student course, we have one primary key, but it contains two attributes. Always we have one primary key, but the primary key could be single or composed. This primary key is composed, so it consists of two attributes. Why we have two? Because if we have one, we cannot repeat. If it's only the student number, then every student can have one course because you cannot repeat the student number. If the course number, then the course could be given to one student. You cannot repeat the course number. But when we have both of them, then we can repeat any one of them, but not repeat both. Now, what is the problem in this design? After we split, this design here is okay. Student has a student number, student name, and major. We don't have any problems here. Leave it. Let's look at the student course. What is the problem in the student course? Now, if I want to add a new course, whenever you want to add a new course, imagine you are trying to add a new course. Can you add a new course without student number? Sorry, I have to take this. Hello. اه اه بصير. لا، بس قهوة خلاص، بس قهوة. باي. Okay, so here We are talking about student course. Every time we need to add a new course, we have to put the student number, which is nonsense. Do you understand the problem? I don't want to add student. I want to add course. I can't. Upon this design, I can't. So I want you to see and feel what does it mean a bad design. Suppose you create a system like this and you give it to your client. You put your client in a problem. They want to add courses. They want to add so many courses regardless about students. They can't. Can you imagine this here? We have student number and course number. So every time I want to add a new course, I must put a student number, which is nonsense. I need to add as many courses as I want without referring to students. So here, this problem needs to be solved. But before we solve the problem, we are showing you what is the problem. So the first problem is inserting. When you insert, you will find a problem. When you update, you will find a problem. When you delete, you will find a problem. So we will find problems in inserting, updating, and deleting. Because to delete a student, if you want to delete the student, you will delete what? You will delete the course. Because if you don't have a student, suppose we have student number 1 and course number 1. Then we want to delete student number 1. All information about course number 1 will be deleted. So there is a problem here, which means this design is bad and this table is not in the second normal form. This table here is in the first normal form. If I give you a question and I give you such design and ask you, check, is this table in normal form 1 or normal form 2? Is it in normal form 1? Is student course table in the first normal form? Yes or no? How can you know? Yes, it is. How do you know? How do you know? No repeating, no repeating groups, no repeating. No multiple values, yes. So we can know if the table in the first normal form or not. Okay, let's understand the second normal form. Before we start checking is the relation in the second normal form, it has to be in the first normal form. Which means I can't take this relation and make it in the second normal form. I must make sure it's in the first normal form. When it's not, then how can I jump to the second normal form? No, I have to go to the first normal form, then go to the second normal form. So this relation here cannot be splitted to achieve the second normal form because it doesn't achieve the first. I have to go step by step. That's why we split it into two relations, and each one of these two relations are in the first normal form. And student here is in the second normal form. But student course is not in the second normal form. How can I tell? Let's look here. First of all, it's in the first normal form. And the primary key comprises single attributes. If the primary key comprises single attributes, then yes, it's in the second normal form. Okay? Any relation, when you look at the relation, if the primary key is single, it's in the second normal form. That's it. So here, the student number is the primary key. It's single. That's why I can tell. When I told you student here, is it in the second normal form? Yes. How can I know? Because it has single primary key. Okay. Does it mean all relations with single primary key is in the second normal form? Yes. Does it mean all relations which have compound or composed primary key are not in the second normal form? No. No. Maybe, look, maybe the relation has compound primary key, but still in the second normal form. So let's understand. If the relation has a composite primary key, then each non-key attribute must be fully dependent on the entire primary key and not on a subset of the primary key. That's the trick. If the relation has composite primary key, I will directly say, no, it's not in the second normal form. No, that's wrong. That's wrong. Maybe it has composite primary key, but in the second normal form. How can I know? Here, the composite is student and course number. Let's look at the dependency. Course name depends on student number or in course number or in both course number. instructor number, instructor name, instructor location, all of these depend on the course number. How about the grade? ماشي بعد البريك. Yes, the grade depends on both, only the grade. But course name, instructor number, instructor name, instructor location depend on only the course number. So this relation is not in the second normal form. Even if we have one attribute, here we have 1, 2, 3, 4. 4 attributes depend on part of the primary key. Even if you have one attribute depends on part of the primary key, then it's not in the second normal form. That's it. So how to know if the relation is in the second normal form? It has to be in the first normal form and single primary key, or composite primary key, but all other attributes depend on both parts of the composite primary key or the entire primary key, not just on parts. Yes, every non-key attribute must be dependent. Every non-primary key attribute must depend on the attribute and depend on the primary key, not on part of the primary key, on the whole entire primary key. If it depends on part, it's not in the second normal form. So it's obvious here, this relation is not in the second normal form. So what do we need to do? What do we need to do? Split. Exactly. Normalize by splitting. How can we split? We should not split randomly. We should split, and when we split, both new relations must be in the second normal form. So, student number, student name, major, forget about it. It's already in the second normal form because it's single. Now, student number, course number, grade. The only one here, I told you, the only non-key attribute depends on both is grade. So I keep both and grade in a relation. The second relation, I will put only the course number, not both, and everything depends on the course number. So we will have course number, course name, instructor number, instructor name, and instructor location. All of them depends on the course number. Course number is the primary key. So here we have 3 relations. Let's check the database in the second normal form or not. Every table or relation must be in the second normal form. Student, is it in the second normal form? Yes. Why? Because the student number is single primary key. Course instructor, in the second normal form? Yes. Why? Because course number is a single primary key. Course grade, is it in the second normal form? Yes. But it has composite? Yes, because the non-key depends on the whole entire primary key. So I can say now the database in the second normal form because it's in the first normal form and it is in the second normal form. Okay, do you think the course instructor relation is good design or not? Not. What problems we will have in inserting? Whenever I want to insert a new instructor, I have to insert a course. Whenever I want to insert a course, I have to insert an instructor. So here the problem for both, adding a new course and adding a new instructor. Whenever add new course, I will put the course number, course name, and information about the instructor. Even I don't have instructor. When I want to add a new instructor, I will put information about the course, even I don't have a course. So yeah, there is a problem. How about updating? I will have problems for updating. If I want to update the instructor name, if I want to update the instructor number, so I will have problems. How about deleting? What if this instructor is not working for us anymore and we want to delete their details from our database? How can I delete the instructor without deleting the course? I can't. So this relation, is it in the second normal form? Yes, because it has single primary key. But is it in a good design? No. Is it in the third normal form? Let's check. The relation to be in the third normal form, it has to be in the second. Yes, it is in the second. So the first condition is okay. All transitive dependencies must be removed. What does it mean? A non-key attribute may not be functionally dependent on another key attribute. Look here. What is the primary key? The primary key is the course number. Let's look at the dependencies. Course name depends on what? I'll explain. Arzu. Tell me. Course name depends on what? On the course number. We have no problem. Instructor number depends on what? On course number. Course number is a primary key. We have no problem. Now, instructor name depends on what? Instructor number. Does it key? Instructor number here, is it a primary key? No, we have a problem. We have a problem. What's the problem? We have a non-primary or a non-key attribute depends on another non-key attribute. This is the problem. And this is the transitive dependency. Transitive dependency means non-key attribute depends on a non-key attribute. So it's transitive. Why? Because now instructor number depends on course number. Instructor name, does it depend on course number? Actually, it is. It is, but not directly. Transitively. Yes, it is, because instructor name depends on instructor number and instructor number depends on course number. So whenever I change the course number, the instructor number will be changed, so the course name will be changed, which means the course name indirectly depends on what? The course number. This is the transitive dependent. Transitive means not depend directly, but transitively. So, in another way, non-primary or non-key attribute depends on another non-key attribute. When you have such case, it's not in the third normal form. What we can do, split. How? Look here. The only non-key attribute depends directly on the course number is course name. So I have to take course number and course name in a separate table. Instructor number, instructor name, instructor location in another table. So we will have from the beginning student, course grade, course number, course name, instructor number. Here, instructor number, instructor name, and course location. Here, the primary key is the course number. The primary key is the instructor number. Do we have any transitive? No, because instructor number depends directly. Instructor location depends directly. Course name depends directly. Course instructor number depends directly. You may tell me here for the course table, if we add a new course, we must enter instructor number. So we still have the problem. No, because instructor number here is not a primary. Yes, I see, but we will go in a break. Instructor number is not primary key, which means when we fill this table, if we leave it null, that's okay. So finally, we will have these 1, 2, three, four relations, and the whole database is normalized. Is it normalized? Yes, it is. Let's have a break now. I will mark the attendance after the break.